In this video, we're going to learn about the other type of special right triangle called the 30, 60, 90 right triangle. We've already learned about the 45, 45, 90, and today we're going to talk about the 30, 60, 90. So the 30, 60, 90 triangle gets its name because it has three angles. It has a 90-degree angle, it has a 30-degree angle, and it has a 60-degree angle. Now, labeling these sides. The side across from the 30-degree angle, the shortest side, is labeled with an X. The hypotenuse across from the right angle is labeled with 2X. And the longer leg across from the 60-degree angle is labeled with X root 3. Remember, I will give you the picture of this special right triangle for an assessment. You just have to be able to accurately label sides on your own right triangles. The steps we're going to use to solve for missing sides in all of these right triangles are the same steps we used for the 45, 45, 90 triangle. Now we just have different labels for our side lengths. So let's look at our first example. Step 1 says to label all the sides of the triangle. So remember, the short side across from 30 degrees is X. Well, if that's 60, that makes this 30 degrees. So this side would be X. The hypotenuse is 2X. And the longer leg across from 60 degrees is X root 3. Remember, I'm getting this from this example triangle here to know which side is X, 2X, and X root 3. Second step. Set the given side equal to the label. Well, in this one, 5 is the number on the given side. And I'm going to set it equal to the label. The label is 2X. So step 3 says to solve for X. Sometimes it's going to be done for us. In this case, X is not alone. Okay, so X is not solved for. To get X by itself, we do the inverse of multiplying by 2, which is dividing. I do not want decimals for answers, so since 5 divided by 2 is not a whole number, we're going to leave it. So 5 over 2 is our X value. So the last step is we take our X, and we're going to plug it in for our missing side. So we have to plug it in for X on that side, and plug it in for X on this side. So for side Y, since side Y is just X, and X is 5 over 2, that's what side Y is. I'm replacing X with 5 over 2. We can't simplify, so that's our answer. For this side, the longer leg, instead of X right here, we have to write 5 over 2. But we have to notice there's still a root 3 right next to it. So I can't just ignore it. So there's still a root 3. I got the root 3 because that's part of the label. I know to put root 3 on top because root 3 as a number is like root 3 over 1, so it should stay on top of the radical. I cannot simplify root 3. I cannot simplify 5 over 2. So that's my answer for X. So we labeled our sides. We set the given side equal to the label. So 5 over 2, or sorry, 5 equals 2X. We solved for X, so I divided by 2. Once I had my X value, I took it, I plugged it in for X on the labels of each of the missing side lengths. Let's try another example from our notes. Step 1, label your sides. So if that's 60 degrees, that makes this one 30. So across from 30, the short leg is X. The hypotenuse across from the right angle is 2X. And the longer leg across from 60 degrees is X root 3. So now we have to set our given side equal to the label. Well, the given side is 4. Set it equal to the label. Well, the label with it is just x. So 4 is equal to the label. X is by itself here. It's already solved for. So at this point, I'm ready to take this x value and plug it in for x in both of those missing sides. So for side u, it's 2 times whatever x is. X is 4. So it's 2 times 4. Well, 2 times 4 is 8. So side u is 8. For side v, x is 4, so I'm going to plug in 4 right here where x was. And there's still a root 3 that we have to keep. I cannot simplify that at all. There's no perfect squares that go into 3, so I leave it. So again, I labeled, set the given side equal to the label. X was already by itself, so at this point I took my x value and I plugged it into the labels of the missing sides. Number 3. So this is 60, which makes this 30 degrees. So you just have to be careful with your labeling. Make sure you're going across from the 30-degree angle, the side that doesn't touch 30 degrees. That's x. The hypotenuse that's across from the right angle, that's 2x. And the long leg across from the 60-degree angle is x root 3. Step 2, set the given side equal to the label. Well, the given side is 7. The label is x. X is solved for. There's nothing with it, so now I can take my x value of 7 and plug it in for x in my missing sides. So for side A, it's 2 times x. So I still have 2, and we're multiplying it by x. X is 7. So side A is going to be 14. Side B, okay, that's x multiplied by root 3. Well, x in this case, again, is 7. And we still have a root 3, so I keep the multiplication of root 3. This cannot be simplified, so I leave it. Let's do a few more. Let's go to number 5 on our notes. So step 1 says, again, we have to label our sides. So across from 30 degrees, the shorter leg is labeled as x. The hypotenuse across from the 90 degree is 2x. And the longer leg across from 60 degrees is x root 3. If that's 30, that would make this one 60. So step 2, set the given side equal to the label. So the given side length is 9 root 2 over 2. We're going to set it equal to the label. The label is x. So in this case, x is by itself. So I need to take what my x value is and plug it in for x in both of my missing sides. So for side u, u is 2 times x. So 2 stays, and it's being multiplied by x. So x in this case is 9 root 2 over 2. So when I multiply, to make sure that I don't mess up my numerators and denominators, I put a 1 as a denominator underneath the 2. This way I know I can match up my numerators, the top, and my denominators, the bottom, when I'm multiplying across. So for u, on the top, the outside the radical, I have 2 times 9, which is 18. And I still have 2 root 2. And on the bottom, 1 times 2 is 2. The last thing I can do is divide these numbers outside the radical. So I end up with u being equal, 18 divided by 2 is 9, and we still have root 2. So we had to do some simplifying there. All right, multiplied numerators and denominators. All right, and I can divide these outsides. For v is x times root 3. So x is 9 root 2 over 2. And we're multiplying it by root 3 because that's what the label says. We take our x value and we multiply it by root 3. So again, I like to put the denominator of 1 here just so I know that tops and bottoms can match up. So on the top, outside the radical is 9. Inside the radical, 2 times 3 is 6. So 9 root 6. And on the bottom, 2 times 1 is 2. So there are no perfect squares that go into 6. 9 divided by 2 is not a whole number. So that is my final simplified answer. Let's do one more. Let's go to number 4. Even though these are numbered differently, but the second number 4 here. So step 1 is label your sides. Well, across from 30 degrees, the shorter leg is labeled with X. The hypotenuse across from 90 degrees is labeled with 2x. And the longer leg, which is across from 60 degrees, it's labeled with x root 3. So step 2, set the given side equal to the label. Well, the given side is 3 root 3 equals the label, which is x root 3. So in this case, x is not by itself. We have to solve for it. So x is being multiplied by root 3. So to undo that, we have to do the inverse of multiplying by root 3, which is dividing by root 3. So root 3 divided by root 3, they're inverses, so they cancel. And the same thing happens on this side. Because I have root 3 on top and bottom, they would cancel as well. So I end up with 3 equals x. So now that I have x, I'm going to take it and plug it in for the labels of my missing sides. So for m, it's 2 times x. X is 3, so I'd have 2 times 3. So m would equal 6. Side m is 6. Side n, the label is just x. So if x is 3, that means that side is just 3. You have to practice these. You have to practice labeling, setting it equal, and plugging it in. All right, follow the 4 steps, and you should be able to be successful in these problems.